Welcome to Chapter 2. We're going to start talking about functions and what that means. Let's go. We are talking about functions, but before we get to that, we got to talk about what a function is. Now, hopefully you've maybe seen some of the stuff in Algebra 1. If you don't remember, that's okay. That's why we're going over it now. So to start off with, before we get into a function, what is a function? Well, it's really just a relationship between two sets of numbers. So think about what we were just doing in the last chapter. We had an x and we got a y. We're trying to find out how many solutions there were for a given equation. Basically, that is just, if I give you this number, I want this number in return. Something like that. It's just a relationship between two sets of numbers. So we call that an ordered pairs. So again, this is like if you're graphing something, you get an ordered pair, like an x and a y. That is a set of number or a relationship of numbers. So there's a couple different kinds of relationships. So we've got a set of ordered pairs. It can be shown in a table. Okay, so you just have a table for every x, this is the y, whatever. We can do something called mapping, which we will see here in just a minute. Or we can do a graph. Hopefully you are familiar a little bit with graphing an equation. Or it can be expressed as an actual equation. So table, mapping, graph, or an equation. Obviously, graphs and equations are the things we're going to use the most, but mapping and tables will still come up. Couple of vocabulary words, just that we're taught using the same words here. The set of x values is called the domain. So the word domain, x values domain. And the set of y values is called the range. So there's two types of people out there that I need to talk to. Number one, is this going to be on the test? Yes, domain and range will be on the test. Domain and range will be on the test. Why is it going to be on the test? Because we're going to see it over and over and over again. So very frequently a problem will say the domain is blank, find the range, or which one is the domain, which one is the range. These are vocabulary words that are not going to go away. So take the time, learn domain and range. So then as we move on, a relationship with distinct points is called discrete. Discrete, making sure that I spell it mildly correctly. And a relationship with connected lines or curves is called continuous. Continuous. So discrete and continuous, we're going to be dealing a decent amount with those, but generally most of the equations that we're going to be playing with in this class are just going to be continuous. You will see things like continuous come back if you take college algebra, pre-calculus, calculus, whatever. That continuous word is going to come back to haunt you over and over again. So we're talking about relationships between two different numbers. What do we call a certain specific set of relationships that is called a function? So a function is a relationship in which each element of the domain is paired with exactly one element of the range, or it has a one-to-one. For every x, there is a y. So for example, if I were to just give you some points, we could say 0, 1, -5, 2, 6, -2, there should be a comma there, 5, 7, and we'll put in our little, this is a set, squirrely brackets. So that is an example of a function. An example of not a function, it would be something like, okay, we've got -7, 2, 6, -1. That's a terrible looking 1. 6, 2, still a terrible looking parenthesis, and so on and so forth. So at that point, it doesn't really matter. This is not a function because we have two x values that have two different y values. So it doesn't have a one-to-one relationship, so it's not a function. So one of the ways that we like to talk about those functions, or a test to see if it is a function, is called the vertical line test. And it is just that. So if you can draw a vertical line and only hit 1 point on each of the on all the x points, then you have a function. So for example, if we were to have a line, so we could draw a vertical line anywhere on this line and only cross it once. So it's got that 1-to-1 ratio. However, let's say like a circle. So if you draw a vertical line through most of it, you'll hit it twice, once up there, once there. So that is not a function because it does not pass the vertical line test. Okay, so as I mentioned, domain and range is a thing that you should know, so let's practice. So the directions here say find the domain and range of each relation, and then determine if the relationship is a function. So if it is a function, then it would have a one-to-one relationship. So that's what we're doing. So let's see here. Number one, our domain. Remember, domain is all of our x values. So if we go through, we're just going to list off all of our x values. So we're going to use our little curly Q brackets and then just list those numbers. So -1, 0, 4, 6. And again, those curly Q brackets just means that this is a set of numbers. That's all that means. So that's our domain. So then our range is going to be all of our y values. Oh no, my pen is dying. So again, we'll just write all of those numbers as well. So -9, -5, 3, -2. So is it a function? Are any of the domains repeated? Nope. It's a one-to-one relationship. So yes, it is a function. So number two, again, listing out the domains. So the domain is going to be all of our x values. So you'll notice we've got a 5 and a 5. So I can already tell you right now it's not going to be a function, but we still got to list out the domain. It still has a domain, but you don't necessarily have to list out the number more than once. Once you list it in there, you're good to go. And it's also good practice to do the lowest numbers to the highest numbers. If you don't list it out like that, I'm not going to take off points or gig you on it at all, but it's a good practice to get into, especially if you are planning on going into a STEM-related field. Just build that habit now. Anyway, so our set, use our little curly brackets for our set. It's going to be -3, 5. Again, there's multiple 5s, so I don't have to repeat it. And 8. So that is our set of numbers for our domain. So then our range is going to be, so there's a 2, 4, -6, 0. So we'll say -6, 0, 2, 4. Ugh. Oh, it's still a terrible racket. Whatever. Is it a function? No. We already talked about it. It does not have a 1-to-1 ratio. So I'm going to let you try some of those yourself. I'm going to skip ahead to 7 just because it's a little bit different. So again, it's a graphical representation as opposed to a list of numbers. And I'm just going to start with, is it a function? And so if we use the vertical line test, so that point only hits once. But if you go here, that point hits twice. So it fails the vertical line test. So we already know that it is not a function. It still has a domain, it still has a range. So whenever you don't see numbers here, just assume that it's like single digits. So like this point here would be -1, 2, 3, and then 1. So it goes up 1. So let's see here, our domain is gonna be all of our x values, right? So we've got -3, I'm just working left to right. 0, and then 1, 2, 2, 3, 4. Hopefully your squirrely brackets look better than mine. Our range, again, is going to be all of our y values. So let's just start from the bottom and go up. So this one down here is -1, 2, 3, 4, 5. Then we've got -1, 2 for this guy. -1. That is 1. And then this one up here, 1, 2, 3, 4. There you go. Okay, so number 9, now we're getting fun, right? So we don't have just single points, we have 2 lines we have to deal with. So again, our domain is all of our x values. So if you just look at all of your x values, so at some point, so right here, there is an x value that it crosses. Over here, there is an x value that it crosses. This arrow means that it goes on forever. So all these points over here, all going to be part of this function. So what we have to do is figure out a good way to write that. Oh no, come back. So if we were to think about it, it's all points that are to this side of that point, or all points that are greater than, what is that? 1, 2, 3, then -4. So we can write x is greater than or equal to, because we do have a spot there, -4. That works. If you want to put it in interval notation, that's fine as well, whatever makes you happy. As long as it indicates to me x greater than -4, we're good to go. So then our y values, what y values does this incorporate? You can kind of do like a horizontal line test if you want. You know, like, okay, does it cross there? Yeah. Does it cross there? Yeah. Does it cross there? Yeah. Does it cross all the way down here somewhere? And the answer to that is yes. Does it go all the way up? And yes. So there is no restriction. All of the numbers in existence are part of the range of this function. Do we have a good way of describing that? Sure, it's called all real numbers. We even have a cute little symbol for that. Again, a normal R would work, but this is my little fancy R. And is it a function? We were kind of already talking about. So if we do a vertical line test right there, it does not pass the vertical line test. It crosses at 2 points right there and right there. So no, it is not a function, and we can just clear this up so you can still see the graph. So 11, 12, and 13, what I would do is I would use your handy dandy graphing calculator. This is an old one, but whatever. And graph it in your calculator, look at the graph, and then you can figure out what the domain and the range is and whether or not it's a function. Most calculators should be able to figure out, or should be able to draw these, whatever they are. So we're gonna see if this works. So I've got an app here that simulates a TI-84 calculator. Hopefully you have your own. So if you come up here and push that Y equals button, it'll give you a similar screen like this that you're looking at. So you're just going to scroll up. Your calculator has like little arrows. So scroll up to, the top one, really doesn't matter, and then you're just gonna enter in the formula that you see. So it already has Y equals for you. So let's see, we're looking at I'm looking at number 11, y equals negative x squared, there's a little squared button right there, plus 3, you'll push enter, and then graph. So this one that you're looking at on my screen, is kind of pretty colors. Depending on what kind of calculator you have, it may look better or worse. Note the y-axis here, is going every 5. I can zoom in. You can as well on your calculator. It's just a matter of how you do it. But this is enough to tell us that, okay, it's a parabola, and the domain, the x values, so you can kind of imagine that this thing goes on forever in the negative direction, it goes on forever in the positive direction. This is just x values. So our domain is going to be all real numbers. Again, we have a cute little symbol for that. So your calculator will hopefully show this a little bit better, but we want to know what this top point is, because our range is going to be anything lower than that top point. So that top point is 3. So you can write that as y is less than or equal to 3. Or you can do interval notation. It would be it would be parenthesis, negative infinity, comma, 3, close bracket, because it does include that 3. And then is it a function? You can kind of imagine your vertical line test. Yes, it is a function. I can also tell you that parabolas are, by definition, functions. So that's number 11 for you. So last part about functions, how do we write them and how do we communicate them? So this talks a little bit more about like kind of the language that we use and the symbols that we use to communicate that this is in fact a function. So for example, if we have like a y equals 2x plus 7, so just a regular equation, if you will, and we wanted to write that as a function, so we would write that as f of x equals 2x plus 7. So the reason we use something like this is this kind of just tells us that, okay, there's a function here and the variable is x, and here are the constraints for that x. A lot of times you can just replace y with f of x. A lot of times that is generally okay, but this is kind of what we use for our functions. This is the notation that we use. And the f is just kind of where we start. A lot of times you see G, H, they just go through the alphabet. It all is just a function, and maybe it's just a different function if you're dealing with multiple functions, things like that. So as I kind of mentioned earlier, so this is like x is the input, and then f of x is the output. I kind of like to think of functions as a computer program. Like you have an input, you input a number, and then it does a bunch of stuff with it, and it poops out a different number. And what kind of different number? That's where the equation comes into play. So then we can evaluate functions. Like I said, you can input a number, and it does a bunch of stuff, and then it outputs, or like I say, it poops out a different number. So we can do that by hand. A lot of this class is doing it by hand, so get used to it. So here's our example right there. If f of x equals this function, find f of negative 3. So that's kind of how it's going to be frequently written. Find f of a number. So that just means that anywhere you see an x, you're going to plug in a negative 3. So in this case, it would be f of negative 3 equals 2 times negative 3 plus 7. So that we just evaluate kind of like how we've normally done. So 2 times negative 3 is negative 6 plus 7, which equals 1. So then we can say f of negative 3 equals 1. So that's what they mean by evaluate the function. Obviously, let's try some examples. So use f of x equals blah, 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 And g of x, I told you we use other letters sometimes, equals all that other stuff for questions 1 through 6. Now, there is a fancy, cutesy way to do this in your calculator, and if you want to figure that out, go for it. That's fine. I'm not going to stop you, but still need to know how to do it. So basically, we're just taking this number and plugging it into this equation. It's kind of all we're doing. So f of x equals f of 9. So that means that's going to look like negative 5 times negative 9. And I'm just plugging it in where I see an x. Okay, and then you're just going to solve that normally. So negative 5 times negative 9 is a positive 45 minus 14, which equals 31. There's your answer. I guess to be mathematically correct, we should write f of negative 9 equals 31. I might make fun of you if you just circle 31, but I'm not going to take off points. So I'm just going to skip straight to number 3, g of x of 0.4. So remember, that's this equation over here, which is slightly more complicated, but, more fun. And you can use your calculators for this. So if you see a decimal or you see a fraction, don't panic too much. It's fine. Everything's fine. So plugging it in, we've got negative 0.4 squared. Remember, that negative sign is on the outside of that x. So that's why I just threw some parentheses around it to make sure that I didn't miss that negative sign. So we'll square this first and then add that negative sign. Anyway, we'll finish up plus 9 times 0.4 minus 1. So 0.4 squared, 4 times 4 is 8, 16. So that is going to be 0.16. So we've got negative 0.16 plus 9 times 0.4 is, so 9 times 4 is 36. So 3.6. And then minus 1. Oh, I'm going to line that up vertically because I need to do things like that. So doesn't matter what order I do them in, so I'm just going to take the biggest one, 3.6 minus 1. Whoops, not done yet. Minus 0.19. So we got to do that. So that's 1. That turns into 5. 5 minus 1 is 4. And then 3 minus 1 is 2. So g of 0.4 equals 2.41. There's our answer. So I'm going to skip right down to number 3. It's got a decimal point. Why not? And you can always feel free to use your calculators for some of the internal arithmetic, but you still got to know how to, the concepts here and kind of how to do it. So find g of 0.4. G of x is right up here. So we're just going to plug in 0.4 everywhere there is an x, and we'll be on our way. So then negative 0.4 squared plus 9 times 0.4 minus 1. So 4 squared is, 4 times 4 is 816. So this is going to be negative 0.16. Yep. Plus 9 times 4 is 36. So that 3 is going to come forward. 3.6, and then minus 1. Okay, so I'm going to line that up vertically because I can't do that in my head. I'm not that good. Doesn't matter what order I put them in, so I'm going to start with the biggest one. 3.6 minus 0.16 minus 100. Boop. So we need a 0 there. Carry the 1. So that's going to be 4. And that's 5. 4 again. And then 2. So to rewrite my answer, g of x equals 2.44. Done. So again, I'm skipping down to 13, and yes, I'm going to let you all do the word problem by yourselves. Good luck. But number 13, it is phrased a little bit differently, so I wanted to point it out. So instead of it giving you x, it gives you f of x. So that means that the whole equation, the whole function equals 34. So this part is the one that equals 34. So that's where you're going to plug in the 34. So you're going to have 34 equals 3x plus 19. So then you're just going to solve it normally. Subtract 19. Of course, I'm not going to be able to do that in my head. So 15 equals 3x. X equals 5. I divided both sides by 3, and then I got x equals 5. Oh, let's circle it. All right, the rest of it you can try, and we'll go over it in class if we need to. I'll see you then.